Alright, you're welcome to Marketech Services, home of professional tutors. So today we'll be considering frame of reference, also in line with motion, and then we'll be treating some of these questions. Let's start with question 1, and it says, a train travels through a station at constant velocity of 15 meters per second. An observer sitting inside the train and another observer sits on a platform. As they pass each other, they start their stopwatches and observed a child on the train running at a constant speed in the same direction as the motion of the train. Now, the observer in the train measures the speed of the child to be 2 meters per second. To be 2 meters per second, yes. Now, the question says, according to the observer in the train, how far has the child moved after 10 seconds? And then according to the observer on the platform, how far has the child moved after what? 10 seconds too. So we're going to solve it this way. Let's take solution. Alright. So our solution will be now solution. So let's have this diagram. For example, let's have a sketch. I see this as my train. Follow me. Let's just have a sketch. And then I see this one as observer that is sitting inside the train. For example, we call this observer A. I see this as a boy that is running inside the train. Yes. They said it's running, the observer A said it's running a speed of 2 meters per second. Now, and this train itself, it's moving at 15 meters per second. So this is a road. Let's say this is a road, the train is moving, and they said there's a platform. An observer is sitting on a platform. Let's say this is a platform, and then this is the observer B that is sitting on a platform. Let's say something like this. So B, both of them, they are observing this boy. Yes, you can see the direction. Both of them, they are observing this boy movement. Both the observer A and the observer B observing the movement of the boy. And then now they said, according to the observer A, which is the first observer, how far has the child traveled or moved after 10 seconds? Now in physics, one thing you should understand is that when they ask how far, just know that it is the distance. And in question like this, frame of reference, there are key things you need to observe from this. One, you have to observe the observer. So you have to check for the observer if they are 2, 3, or 1. Secondly, you identify the object, and then again you identify the direction, because direction matters, right? So if there's a change in direction, that means the value we're going to get will be different. And one funny thing about frame of reference is that frame of reference help us to knowing two things. One, two observers might be observing the same thing, but they will not have the same answer. Why? Because they are not using the same approach. They're using different approach, so they will have different answers, but they are correct. Why? In the law of physics, if both of them, they are using the law of physics, they are correct. They might not use the same formula, they might not use the same approach, they might not observe from the same perspective, but their answers are correct irrespective of variety in values. I don't know if you get what I'm saying, but then let's proceed. So we start saying that, of course, we're given that before this diagram, we're given that V is equal to 15 meters per second, U prime is equal to 2 meters per second, u prime because it is dynamic, is in motion, and then what again, our t is given as 10 seconds. Yes, so these were the things given, right? Now first they say we should check how far the guy traveled or the child traveled after how many seconds, after 10 seconds. So this how far, the action of distance, of course we know that distance is equal to speed times time itself, right? So we can now say that let distance be x prime. Yes, x prime. So let's distance be x prime. Therefore x prime equals our speed, can say u prime, and then times our t, time, which is t, right? So substitutionally we have that x prime equals u, our u was given as 2 meters per second, times our t was given as 10 seconds. Of course seconds cancel, we are left with meters, so 2 times 10 is equal to 20. Therefore x prime is equal to 20 meters. So that is what the observer observed. Now for b, this is for a. Now for b says that according to observer on the platform, that's observer B, how far has the child moved? Yeah. So in calculating b, since b is observing the movement of the boy on the train, and now a observed the movement of the boy on the train, because a now is inside the train. So we believe that a is the same thing as the speed of the train, which is 15 meters per second, right? So a has no business with the velocity of the train because a is inside the train already. But for b to observe the distance of this boy or the movement of this boy, b needs to consider the movement of the train. What I'm saying is that observer on the platform, for him to call or for him to calculate the distance covered by this boy on the train, he needs to first know to consider the movement of the train, right? So that is what makes them different. Like I said, they'll have the same answer, but they'll move with different approaches because observer B is not inside the train. He needs to consider the velocity of the train because train is moving per second and the boy is on the train moving same per second, right? So movement of the train needs to be considered in this case. And then let's, according to observer B, can say that according to, let's quote it, observer B rather. Now we can say using, there's a formula called Galilean transformation. Let's say transformation, yes. In this Galilean transformation, we have that x prime equals x minus bt. Now, x prime equal x is the same thing as change in the coordinate of x. That's what it means. Our v is the velocity of the train, and then our t is the time taken. Are we getting it? Our v is the velocity of the train and time taken. Now, there is no need using u again. I mean the velocity of the boy. Why? Because it has already been calculated into our first distance x prime. So if we are recalling the formula for Galilean transformation, since we have x prime equal to x minus vt, we just need to quote the formula because the value of u has already been calculated inside x prime, right? Now that we have the value of x prime, what we need to do is to calculate for x. Of course, vt is given, v and t are given, and then x prime is also being calculated. So But can say but x prime is equal to 20 meters. Therefore, making x the subject, all this one can just know, making x the subject, we have that x equals, of course, x prime transposing to this other side, rather x equals x prime plus these changes, right, plus vt. Yes, vt. So this is what we have. So it's same thing as x prime plus what, vt. Substitutionally, we have that x equals, the value of x prime is given as 20 meters plus value of v is given as 15 meters per second times t, 10 seconds. Alright, so that seconds go, right? We now have that this same thing equals 20 meters plus 15 times 10. 10 times 10 is 100, 5 times 10 is 50. So we have that 15 times 10 is equal to 150 meters. Now therefore x is equal to 20 meters plus 150 meters.